Let's look at factoring special cases. So first we will look at factoring difference of squares. And there is no sum of squares, there's only a difference of squares. So the difference of squares formula, a difference of squares is something squared minus something else squared. So a squared minus b squared. So we would factor that by setting up two sets of parentheses. We would take the square root of the first term, which is a, take the square root of the second term, which is b, and in one set of parentheses we would put a plus in between the terms, and in the other parentheses we would put a minus in between the terms. And it doesn't matter which parentheses we put the plus and which one we put the minus. So let's look at an example. Here we have 4x squared minus 9. So when we're factoring, we would always look for our greatest common factor first. But there is no greatest common factor here. But we do notice we have a perfect square minus a perfect square. So what squared equals 4x squared? 2x quantity squared equals 4x squared. So in this case, a is 2x. And what squared equals 9? 3 squared equals 9. So in our case, b is 3. So setting up for the right-hand side of the formula, we're going to set up two sets of parentheses. And then we're going to fill in the parentheses with a plus b and a minus b. But a is 2x, b is 3, and in one parentheses we'll put a plus, and in the other one we'll put a minus. So 4x squared minus 9 factors to 2x plus 3 times 2x minus 3. So another type of special case is looking at factoring perfect square trinomials. So one formula for that is a squared plus 2ab plus b squared equals a plus b quantity squared. We can also have the formula a squared minus 2ab plus b squared equals a minus b quantity squared. So let's look at an example. We have 9x squared plus 24x plus 16. So we have a perfect square as our first term, a perfect square as our last term. Again, we did not have a greatest common factor at the beginning, but we do notice we have a perfect square as the first term and the last term, so we are going to try to use one of these formulas. Our middle term has a plus, so we are using that first formula that has a plus for the middle term. So what squared equals 9x squared? 3x. What squared equals 16? 4. Because we're using that first formula, we put a plus in our parentheses. So this is potentially factoring to 3x plus 4 in parentheses squared. But we do need to check something. We need to check this middle term. So we need to see, does 2 times the a term times the b term equal our middle term? Does 2 times 3x times 4 equal 24x? 2 times 3x is 6x times 4 is 24x. 24x equals 24x. So yes, this checks out. And our second example, this 9x squared plus 24x plus 16, this does factor to 3x plus 4 quantity squared. Let's look at a second example. 8x squared minus 24x plus 18. Okay, so we've got three terms. There is no greatest common factor here. Oh, wait, yes there is. All of these are even numbers. We can factor out a 2. When we factor out a 2, we're left with 4x squared minus 12x plus 9. Okay, so now we notice in the parentheses, our first term and our last term are perfect squares. Okay, so let's try to use one of our perfect square trinomial formulas. So I still have our 2 out in front. We're going to put up the parentheses squared for the right-hand side. We have a minus, so we're actually going to use the second formula. So our first term is 4x squared. What squared gives us 4x squared? 2x. What squared gives us 9? 3. Since our middle term is minus, is a negative, we're going to use the second formula. So we're going to put a minus in our parentheses. So this is potentially factored as 2 times parentheses 3, so 2 times parentheses 2x minus 3 quantity squared. So let's double check our middle term. So does 2 times 2x times negative 3 equal our middle term, which is negative 12x? 2 times 2x is 4x times negative 3 is negative 12x. Negative 12x does equal negative 12x. This checks out, and this does factor to 2 times 2x minus 3 in parentheses squared.